We are on page 35, Calculations and Energy Conversions. Remember that, by the principle of conservation, energy cannot be created or destroyed. When energy is transferred from one form to another, the total amount of energy therefore remains the same. This is what we mentioned in the previous lesson. When climbing up a hill, the total kinetic energy used to climb up is transformed to gravitational potential energy. We can also write it as GPE. When going down, all this potential energy is transformed back into KE. Therefore, in this case, the potential energy at the top has to be equal to the kinetic energy at the bottom. Since we said that energy cannot be created or destroyed, all the potential energy that he must have at the top, all of it has to be turned into kinetic energy as he moves down. So mathematically it would be that mgh, which is the equation for potential energy, has to be equal to 1/2 mv squared, which is the equation of kinetic energy at the bottom. We will work out a couple of examples for these later on. Similarly, when driving a car, kinetic energy is being used. For the car to come to a complete stop, work must be done by the brakes. In this case, in car brakes, when somebody presses the brake pedal, what you are doing is turning the kinetic energy into heat energy, sometimes even a little bit of sound when the brakes squeal. By conservation, the amount of work done to stop the car must be equal to the kinetic energy of the car when moving. So we had already talked about work. When you press the brakes, you are applying a force and using energy, making use of energy, which is work done. So work done here will be equal to kinetic energy. The energy supplied by the person on the brakes will be equal to the kinetic energy of the car. We have an exact example of one of these later on. This can also be that work done will be equal to potential energy as well. Because since potential energy can be turned into kinetic energy without any losses, then the work done might also be equal to potential energy. Therefore, force multiplied by distance might be equal to mass times gravity times height. These relationships can be used whenever energy is transformed from one form to another. It is always assumed that no energy losses, such as to heat or sound, take place. Whenever we are going to do calculations, we will always assume that any energy being supplied will be converted into the required energy at the end, even though in real life there are always energy losses, especially to heat and sound, which is why they're being mentioned here, which makes things a bit less efficient. However, the principle of conservation of energy will still be true. For example, if I have 150 joules of chemical energy as fuel in a car, okay, so 150 joules of fuel, the car will not get 150 joules of kinetic energy when those are being used, because the car will turn the chemical energy into not only kinetic energy but also heat and sound. So in the case of a car, if I have 150 joules of fuel, I might get 100 joules turned into heat and sound, and only 50 joules that will be turned into kinetic energy.